Let's now try to add some labels to our Pascal algorithm. Before I do that, let's get a big picture very clear. So what we're going to do is we're going to make some modification to this algorithm over here. If you remember from the previous video, this will be the manual part that we can touch. And we're going to add labels into this algorithm. After we have added the labels, before you can do anything else for analysis, you have to make sure this TLA plus predicate would reflect whatever changes we have made over here. So you have to make sure you click on the translation button that I just showed to you, right? After we have added the labels, make sure this part over here is also up to date by translating, by generating the latest translation. That's always something you want to remember. But I think the tool in some scenario, it might just remind you to do that anyway. But I would say maintain a good habit of doing that yourself, always. And why do we want to add labels? Let me just mention that in a few seconds, and then we'll go ahead and do the labels, which itself is actually rather straightforward. If you look at the syntax for the generated TLA plus predicates over here, right? You can see we got equal here. You can think about the equal can be read as is defined as. We say vars over here is defined as a sequence containing the variables n, I, pc, and stack. Similarly, we say that the init predicates, of course, for initialization, is defined as the conjunction of these predicate, and these are before actually predicate, before after predicate. Well, that's something we'll go over a little bit later. And what we really want is to have the name over here to really be more informative rather than just label number 1, label number 2, and also label number 3. And these label names are somehow implicit for your source Pascal algorithm when you do the translation. But if you add some explicit label names in your source Pascal algorithm and retranslate it, you will actually have some very informative name. That's really something we'd like to have. And is adding labels really necessary? I would say if your goal is to really verify your model and try to find defects or find errors. And usually when you want to interpret any counterexample error trace in the TLC checker, which we'll see later, they always refer to the label name over here or refer to the before after predicates. So if you only got label 1, label 2, label 3, the very systematically generated symbolic name, you may easily get lost in the debugging process. So what you really want is to have some very informative names. So when you read over the error trace later, it'll be much easier for you to realize what the problem is and fix your model accordingly, right? That's really important to know. I'll try to write it down briefly for you. But let's now try to add the labels. Okay, how about this? Let me just write a comments for you so you always remember why we are adding labels. Okay, let's now just do a single line comment will be okay. For easier reading of counter error trace. That's how the TLA plus tool actually called it, or the TLC checker calls that. How reading of counter error trace in the TLC checker. We add labels to individual updates in the algorithm. The idea will be each update in your algorithm is going to be labeled with the explicit name, so they will be turned into some states, which is what a translation will do. Okay, let's take a look. The exact rule about adding labels in TLA in the TLA plus tool, there's got to be some rule, but it's not very clear actually for you to learn as a beginner. So I would suggest the following. Whenever you want to add labels to your algorithm, the best way to do it is to add it at every level. Okay, and when as a beginner, you will definitely run into the mistake where when you try to do the translation, the tool will actually tell you that you're missing certain labels. In that case, what you got to do is look at which line is complaining about the labels and try to go to that line and add a label accordingly. That'll be the best way to get around. Okay, but maybe once you develop more and more example, you have a very good sense about how to add labels accordingly. Okay, so for example, I will just add one label over here. So this one here is about when we call the ML out. So it's like the central scheduler has chosen this ML out to really occur. right? So why don't we say this label here? And the label here would be very similar to like a label in assembly language. Maybe in your 2021, when you learn about assembly, you know, you can always put a label over here and go to that label, right? That's the idea. So let's say ML out occurs over here and colon. This is what we had before. And now we are saying that whenever this occurs, it's going to be treated as a name label, which is called ML out occurs. So later on, whenever we see ML out occurs, this string literally, so that means it's really referring to line number 47, right? You can think about what we had before, label 1, label 2, label 3, is more referring to line number. That's not very friendly for human to read or to interpret. So that's why we're adding this label name over here. Let me try to retranslate right away because I have already modified the algorithm. Let's see what's going to happen. Okay, if I try file, and oh, by the way, you should always make sure you actually save the file before you try to translate, right? Make sure there's no star on the tab over here. Always remember. So if I go for file and translate Pascal algorithm, you will see I got some parsing errors. All right, don't be too scared. In this case, all you got to do is telling you should at least add labels to line number 25, 30, 40, and 55. Let me add them first, just to get the translation tool happy. But in reality, I would like you to add more labels just to be complete, so that when we actually see the final translation, it will be more complete and easier for you to to interpret. Let's do that. Okay, just remember 25, 30, 40, and 55. Okay, let's go to line 25. Line number 25 is over here, right? Even highlighted for you. So this will be the action for ML out event, right? Remember, we put every event into a procedure, right? Procedure abstraction. So M is assigned to n+1. So this should be the first one, line number 25. Let's give a name. So let's say ML out action. All right, so that's one. Just save it. And of course, before we retranslate, this might still stay here, but that's okay. We just added the label. So we are saying that for this particular action over here, for this ML out events, is going to be labeled later just by ML out action. Okay, that's something we're going to do. And then what about line number 30? Well, this will be the action for ML in. So why don't we do that? Okay, let me put it here. So ML in action. All right, so that will be the second one. And line number 40. Okay, can I just click on that? I wonder if I click on that, it's not really linking me to the right place. So let's not worry. You can see it's showing line number 40, but it's linking me to line number 25. Let's not worry. Let's go to line 40. Line 40 is exactly this loop over here, right? It's about the iterative central controller for scheduling. So here I can just say loop. So that's okay. Just give a name. Okay. Of course, the only constraint is the name of your label shouldn't really clash with any keywords. And I believe if you try to use duplicated label name, it might give you an error. I'm not sure, but it's not a good practice to have duplicated label names anyway. Right, 40 and also 55, which is exactly over here. It's about incrementing the counter for the scheduler, right, to make sure it's bounded. So this will be, you can just say I incremented or just progress. It's the progress for the central controller. All right, so now we have added all the lines that were indicated by the Pascal translation tool. So what I'm going to do is I'm going to say file, translate Pascal algorithm. You can see now there's no more error. So it seems like these are the minimum these will be the minimum number of labels we will have to add. But you might be wondering, what about here? We added the call ML out and label that as ML out occurs, but we didn't label ML in over here. But somehow the tool doesn't complain. So that's why I said the rule about labeling, I'm pretty sure it's well defined in the behind the scene for the tool, but somehow it's not very clear for us as the user. So I would suggest for us, for our purpose, for our later debugging purpose, we just add label to every construct over here. I'll show to you. So this one here, let's say ML in occurs. Even though we're doing more than necessary just to make the in order to make the tool happy, but I think we're doing ourselves a favor for later. Okay, of course, make sure you have no typo. MLN occurs, and then also this will be, you think about this is like a guarding condition, right? We want to say if we are able to get here, that means we're checking the guard of the events. So why don't we say over here, this could be the guard. Okay, so let's say ML out guard. And of course, if you're not really feeling comfortable about adding so many labels, I would suggest you play with the example over here and regenerate the model and do the model checking later to see to what extent you really want to add a label. For now, I'm just going to go for the extreme to add labels for every possible line. But for your purpose, either for the lab exercises or later for the programming task, you can do whichever level you like for adding the labels, as long as it helps you debug the error trace. That's the most critical point. Over here, this will be MLN and guard over here. Right, so we got these two labels just for checking the guards for the two events. Of course, if you got more events, you got more guard checking and more labels. And also this either over here will be the non-deterministic choice we have to make to select the event's occurrence. So here I can also put choice, right? So I believe these are the maximum number of labels you may add to your algorithm. Of course, if we change the pattern of the algorithm structure, it might change a little bit, but you get the idea, right? You want to add all the labels so that the translated TLA plus predicates will be the most intuitive and the most informative possible. Oh, by the way, you don't really need to add a label for return, but you need to make sure you include the return inside the MLN. Otherwise, you will see some logical error in your generated state diagram. Okay, just make sure always include the return keyword at the end of each procedure, but you don't really need to put a label for the return statement itself. Okay, hopefully that's clear. And let's now try to say file and then translate Pascal algorithm. You can see there's no error over here. That's good. And if you scroll down over here, you will see that now we got, for example, init is still always there with or without the labels, but we got ML action, and also we got ML in action, and also we got the loop, we got a loop, and also we got a choice, and we even got ML out guard, right? So you now see it's much easier for us to see the connection from the translated TLA plus specification back to the source Pascal algorithm. So what I want to do now is to briefly compare the algorithm and the automatically translated TLA plus specification side by side so you can see some connection over there. Let's now do it.